Hey, third grade. Today we are going to start an experiment where we take a look at what happens to water molecules when they are heated and when they are cooled. Um, Now, as you can see, I'm joined by my lab partner here, Blue. Blue, you want to say hi? Just sit. Sit. Okay, stay there. And together, what we're going to try to do in order to find out what happens to water as it's heated and cooled, we're going to try to make our own thermometer. Now, the first thing I want to show you is some of our materials here. What we have is our vial, which we will use as the base of our thermometer, an air stopper, okay, that will just separate the outside water from what we have inside of here. We have ice water. There was some ice cubes. They've melted down, but still very cold. And then some room temperature water here. All right. In the microwave, we have some hot water that just getting heated up for right now. I think you just heard it beeping. And when that's ready to go, we'll be able to start. But first, we want to prepare our experiment. Sit down. Sit down. Come on. Sometimes it's great working with a lab partner, and sometimes they can be a little distracting. Hopefully, this goes well. Let's take a look here at our thermometer. The first thing we need to do is add blood. Okay, food coloring, not blood. And we're going to do about 5 drops just to make it really dark. And then we want to add, Blue's very interested in that. Then we want to add some room temperature water. So I'm going to use a syringe here for my room temperature water. And the only reason I'm using this is that I don't want to make a big mess. Okay, so we've got some water in here. Perfect. Now, this is what we are going to use to create our thermometer. Now, I have a real thermometer here, and our goal is to make something pretty similar to that. Let me back this up a little bit. Pretty similar to this thermometer. So what I'm going to do is, just like this has this long straw, the inside liquid can move up and down. We're going to create that with a straw. Sit. So here's my straw. I'm going to take my stopper, and I'm just going to slide this straw in here just so that it's deep enough that it would reach the water. We want it to go into the liquid there. And that should do it. We just got to push in our stopper. All right, I like the, there we go. So, hey, sit. So you can see that it's just barely sticking out. Now that only rose up to the top because of the pressure that we've created, okay? Now keep in mind, in here, it's a room temperature water. We could actually measure the temperature. It's coming in at about 60 degrees Fahrenheit, 60 degrees Fahrenheit. So that's a little cooler than room temperature, but that'll work. So now we want to think, what do you think is going to happen when we take this water and we put it into hot water? We're going to start with our hot water. Now, I have to go get it from the microwave. In the meantime, Blue is going to keep an eye on everybody. Blue, please watch the class. Oh, you're doing a good job. All right, so we've got our really hot water here, fresh out of the microwave. And let's take a quick check at how hot it actually is. Oh, wow. It's going up over 160 degrees Fahrenheit right now, so it is warm. Okay, let's take a look at what happens. Hopefully you've already made a prediction what's going to happen when this room temperature water gets submerged into hot water. Let's take a look. I'm going to bring the computer closer for this. Blue is very interested, as you could see. Here, what do you think is going to happen? Oh my, it's about to go over the top. Look, Blue. Oh no. Okay, we are losing water. It is flying out of there. So all of that all of the water here inside of our thermometer is flying out the top. Now, hopefully this can cool down a little bit, okay? Now, when we started, that water was right about here, right? And then it started overflowing out of the top. Well, let's see what happens when we then put it into ice cold water. Let's see. I imagine it's going to make the ice. Oh, it is coming back down quickly, right? It's even lower than it originally was, lower than where we started. And if you can really see in there, it's not even in the straw under our stopper anymore. So in the beginning, our red liquid was up to about here, that water and food coloring. When we put it in the hot water, it overflowed. And when we put it into the ice cold water, it has now come all the way down back into our main vial here and out of the straw. So we need to think about why this is happening. Blue is a little upset, I think. He's ignoring me now, but he's had a long day here of science experiments. What we had there was the water that was in our thermometer. We're just going to refer to this as our thermometer right now. When it was heated, what happens is the water molecules get hot and they expand. They expand. And when those molecules expand, imagine them running and moving all around. And that's why they climbed right up our straw. They were looking for any place to go. Okay. And the only way to go was up our straw. So the water molecules expand. And when they expand, that's what makes them less dense. The molecules are spread out, so they're less dense. And what we learned about things that are less dense is that they float, right? Now, when it was put into the ice cold water, those molecules contract. They contract, they come together, and they become very dense. But they contract and they sink. They become really dense and they sink. So what I need you to remember is heat expands, cold contracts. Okay? And we could see that with our thermometer here. And one thing I want you to think about is, what could we do to this straw to make it more like our thermometer here? How could we make this water thermometer a better thermometer like this one? What could we do to make this more useful? I want you to think about that when you're answering your next question. Now, the last experiment we have here for today is we are going to take a look at what happens when water freezes. So we took a look at what happens when water is heated up and when it is cooled down, right? When it's heated up, it expands, it becomes less dense, it floats. When it's cooled down, it contracts, it becomes more dense, and it sinks. Well, what happens when water freezes? I hope that you're all thinking right now, ice cubes float. So we want to think, well, why do they float? That must mean that they are less dense. So we're going to figure out why that is. And what we're going to do is we're going to take our syringe here, and I'm going to fill it up to exactly 30 milliliters. Okay, exactly 30 milliliters. We need to get the air bubbles out. So I knock all the air bubbles up to the top, and I can push a little bit out to get those air bubbles gone. And we need to fill up a little bit more. All right, and we have now a syringe filled with exactly 30 milliliters. Okay, see how that top black line is right at the 30? And what I'm going to do is I'm going to go put this in the freezer, and we are going to check it out tomorrow after it freezes, and we're going to see, do you think the water in here contracts, or do you think it's going to expand? Think about what you know about ice already to determine, is it going to contract? Is it going to stay the same? Or is it going to expand? Well, let's put it in the freezer and we'll take a look. All right, we have our frozen we have our frozen syringe here. Now, I accidentally dropped it when I was pulling it out of the freezer, and I knocked the top right off of it. It just broke clean off. But that wasn't part of our experiment, so that's okay. What we have here is that the water molecules expanded, because as you can see, when we started this, we only had 30 milliliters. And now we are at 32.5 milliliters. So that means that the water molecules expanded, okay? They are now taking up more space, which makes them less dense, which is why ice floats. It expands, it becomes less dense, and it floats. So if we had a glass of cold water, hot water, and ice, what we can determine here and conclude is that the ice cold water will sink to the bottom, the hot water will float on the top, and above the hot water will be our melting ice cubes, because they will float, but eventually they'll melt in our hot water. So we've learned a lot here today. I hope these experiments were helpful. And thank you for participating with me and Blue.